So without further ado, Liam, go ahead and take it away.
All right, thank you. Okay, so this presentation is a little bit on the long side, so I'm going to go decently fast. I'm sorry in advance, but there's a decent amount to cover. Okay. The overview, I'll start off by introducing the problem we're trying to solve, and then I'll go into what we've done with Japanese-English Parallel Corpora, go into separating formality from topic, which is, I'll get into this, of course, and then I will conclude and talk about future work. All right, so let's say that you're a Japanese-English translator and you're working on a movie script. The line that you're working on is in a scene where an employee is talking to their boss. The employee asks their boss, "Have you seen the documents I sent you?" As a translator, it's important to not just translate the meaning of the sentence, but also you need to make sure you translate the register of formality properly, or else it's going to come off as really offensive and rude. So when you translate this, there's two options. The option that has the X next to it is very casual, and the option that has the check next to it is very formal. As you can see, we use the humble version of the verb to send and the honorific version of the verb to see. Honorific raises up the person you're talking to, and humble lowers yourself. This is really important in Japanese. I have another example that sort of demonstrates this. So this is an email from myself to my Japanese professor 3 years ago. And hopefully no one that's watching this knows Japanese, because I'm cringing having to show this. My advisor convinced me to show this. What I wanted this email to sound like, oh, sorry. There's a bit of a feedback. Okay, cool. So what I wanted this email to sound like was like this. What this actually sounded like was something along the lines of this. Hey, yo, teach, got that homework done? Phew, Canvas link was down, so I don't know. I put the file here. Might be. What I'm trying to get at is this was incredibly informal. And when I came to class the next day, my teacher actually asked me if I thought he was a kindergartner, and then imposed a mandatory must speak with formal rule in class. So that's when I learned this lesson. It is incredibly important to not just translate the meaning, but also the formality of sentences. Google translates close to doing this, kind of. So when I type in, "How are you?" it translates it formally, but I type in, "Hey, how are you?" and it translates it informally. So that's good, right? Well, not quite. The verified checkmark actually means that a human had to go in and tell Google Translate that this was actually the correct way of doing this. So in fact, Google Translate really doesn't do this. You can imagine a machine translation system that would go something like, you take the English sentence and then you put it into a automatic formality estimation classifier. It tells you how formal it is. And then you can put both that tag and the sentence into machine translation. And then you would get out the proper formality sentence. And this has actually been shown by previous work to increase BLEU score, which is an accuracy metric for machine translation, by up to 10 points in certain categories, especially in the formal categories, because formal is somewhat rare. So our goal is to improve that green box. We're trying to improve the sentence level formality classification in English. This is applicable in a lot of areas that aren't just Japanese-English machine translation, but that's the one that's most relevant to me. So anyway, okay, what is formality classification? So let's start by taking an intuitive look at what formality actually means in English. So for the people watching, which one do you think would be formal, and which one do you think is informal? Which of these two sides? Yeah, so I think it's pretty clear that, that to most of us, the left side seems pretty informal and the right side seems pretty formal. But how did we know that? Like what about these sentences told us that this was informal or formal? Well, so we can see a couple of surface level signs for formality in English. So, you know, proper spelling, proper punctuation, use of precise speech, higher levels of politeness, but these aren't really all that satisfying, you know? So these show us the surface level symptoms, but we want to know what the cause is, right? Like, what actually is formality? It's not contractions, it's why do we use the contractions? Well, I'd like to propose that formality can be encapsulated within this idea of the speaker relationship. So there's a lot of different disparate definitions of formality across the literature, and a lot of them have very distinct, subtle differences, like the power relationship between the two speakers, the amount of shared information, but all of these have one thing in common, and that's that these things have to do with the speakers, the people who are talking, rather than the actual content of the sentence itself, what the sentence means. We can think of an example where if you're watching a news story, the news anchor can talk about some event that's happened very formally, but then you can relay that event to a close friend in a very informal way while preserving the meaning of the sentences you say. So we can, through this example, we can see that the formality is less about what the sentences mean, but more about the relationship between speakers. We can use this idea to sort of frame our understanding of the previous literature on formality estimation and kind of see where we can improve stuff. So just really quickly, sentence formality classification is the task we're going for. Given a sentence, we want to predict whether it's informal or formal. There's generally two types to this. One is the binary prediction, and the other one is a categorical prediction, which is rate a sentence on a scale of -3 to 3. And there's some examples below. One simple way to do this, it was developed here at Penn, is we can take the log odds ratio of words. So we have a corpus of formal speech, so say a bunch of transcripts of the UN, and an informal corpus, i.e. some phone conversations. And we can take each word in a sentence and we can check, is it more likely to appear in the formal corpus or the informal corpus? We do that by log probability. And if it's more likely to appear in the formal corpus, we give that a score, more formal. And if it's more likely to appear in informal corpus, it's more informal, and then we average all of the scores and we get a formality rating of the sentence. The correlation that this gets with human annotators, for the words, it's okay, and for the sentences, not so great. We can do a lot better. This is a solid baseline, but we can do better. So the main way that this is done is, so I should say in 2016, Pavlik and Tetrault decided to decide once and for all what we use to classify formality. So they chucked a bunch of features into a big ridge regression classifier and tried to see which one of them would perform the best. A lot of these features, parts of speech, you know, the subjectivity of the word to vec is a representation of words' meanings. This did really well. It got Spearman correlation of 0.7, 0.75. It's still considered the sort of gold standard for what we should do with formality classification. Just take a bunch of features and then see what happens. But I'd like to propose that this result might not be all that it seems. So let's take a look at what features are indicative of formality by this classifier. So we see that n-gram, and n-gram is just, you know, sequences of specific words. And then word to vec, like I mentioned, is the meaning of the word in like a vector representation. And these are the two most indicative features for formality. Both of these two features are topic related elements. They're about the meaning of the sentence, and they're not about the relationship with the relationship between speakers, or I should say they're not stylistic elements, they're semantic elements. This is bad, as we've previously established. So how should we fix this? So I propose that we can use Japanese to fix this. So here's the overview of the approach that we're gonna take. So we're gonna take a Japanese-English parallel corpus, and now this is a corpus of sentences that are translated. So we have English sentences, and we have the translated Japanese versions. We're going to put the Japanese version through a Japanese formality recognition machine, which basically checks to see what register the Japanese is in, formal, informal, or polite. It will give us a tag. And then we can just train on this English data. This is labeled data. And then we can train a sentence formality classifier on that labeled data. Importantly, these labels come from the Japanese registers. And the Japanese registers denote the speaker relationship. Right? You use formal speech with someone who's of higher status. So this should be agnostic to the sort of issues that happened in the previous work. Okay, so in order to do this, we need three main components. We need the parallel corpus, of course. We need a good formality recognition machine, and then we need an algorithm to classify. So step one, we have to choose a parallel corpus. What would our ideal parallel corpus look like? Well, it should be large, preferably over 100,000 sentence pairs, and this is because the next largest formality dataset is 100,000 sentence pairs. So we want to be the largest, of course. We want it to be well aligned, which means the translations actually match each other. We want the translators that create the dataset to be experienced so that they preserve formality and they generally know what they're doing. We want the topic to be very varied, and we want there to be a lot of different domains of speech. And really importantly, we want to make sure that there's a lot of different speaker relationships in here. We want to make sure that, so for example, a corpus like Wikipedia corpus, there's only one type of speaker relationship there, and that's person who's writing a Wikipedia article, formal, who's higher status, and then you, the reader, lower status. There could be a lot of different topics talked about, but if there's not a lot of different speakers, then we don't get a good spread over formality. So what we picked for this project was the Japanese-English Subtitle corpus, and this is 3.2 million English to Japanese sentence pairs, and it was created by crawling different repositories for subtitles online, where fans of anime and manga can put their translations online for free. This was heavily filtered for alignment at both the caption and the document level. So does this work well? Does this actually accomplish what we want? Is it large? Yeah, definitely. Is it well aligned? Well, Japanese and English are notoriously difficult to align. I'll get into why this doesn't matter a whole lot, but suffices to say that formality is local to an interaction, not to the actual sentences. So it doesn't matter if the meaning is a bit different, as long as the same two people are speaking, the formality will be the same. The biggest issue with JESC is actually the lack of experienced translators. Since these people are fan translations, they tend to take a lot more liberty with their translations, and we'll see that later on. It definitely does cover a lot of domains, and it definitely has a lot of different speakers because we're talking about TV shows, and there's a lot of different characters. Okay, so the second component is the formality recognition classifier. Cool, so quick overview of Japanese formality. I talked a little bit about this before, but let's talk about it more formally here. So there are 4 registers. There's the plain register, used with friends and family or informal. There's polite, which is used with acquaintances. And then there's the 2 formal registers. At the bottom, you can see the conjugations of verbs. These are usually expressed in verbs. The polite register is often expressed by conjugations of verbs or different forms. So miru, which is to see, goes to mimasu. Iu, which is to say, goes to iimasu. The problem is that the formal register is most commonly expressed in alternatives to common words. They take the polite verb endings, but so goran ni narimasu is the formal version of the verb miru. This makes the formal register a little bit more difficult to classify than the polite register because we have to have a big database of all of the possible formal verbs. So previous work has done this problem by tokenizing Japanese and looking for a bunch of different verbs. As you can see, the amount of formal verbs they're looking for is very large. This is good, it gets decent performance, but it seems a little bit cumbersome, and I think we can do better, especially because some of these keys actually conflict with each other, and then some of the other keys just seem way too small. Like, there's no way that da doesn't appear anywhere else in the entire sentence. So we can do better. How exactly are we going to narrow down this list of keys? Well, so remember the goal. We want the Japanese sentences that are most likely to make the human translators write English formally, because at the end of the day, all we care about is the final formal English. So what we can actually do is do a little bit of a bootstrapping variation of this. So we'll take the parallel corpus, and we'll actually, instead of taking the Japanese, we'll take the English, put it through a formality classifier that was trained on manual data, get a label, and then we can train on Japanese. We're only going to do this once just to get a good idea of what is and isn't formal, what keys do and don't correspond with English formality. But once we do, we can kind of get a good idea of what we're looking for here. So if we rank all of the keys from the previous work, we can see that the informal keys they're kind of inconsistent. The polite register keys seem to be pretty consistent, and the formal register keys didn't even appear because they were just too rare. So it looks like we're going to go with these sets of polite keys, and I've noted by asterisks the keys that I'm going to go with. The final version, the final form of the Japanese formality recognizer is we string search on untokenized text. If a key is present, we label formal, and if no key is present, then we label informal. And these are the 7 keys that we chose. Okay, cool. So now we have that. Time to go do the sentence formality classifier. This is simpler than you'd think. I'm going to use BERT. BERT is very common, very popular. It's a pre-trained model, so you just download it, and then you fine-tune it on new data, and then you go forward. Talking about BERT, I don't have too much time to begin with, so I'm going to save that for a different NLP presentation. Feel free to look it up on your own, but it is very good and very popular. Cool, so now we have all these components. So we put it all together. We run our Japanese formality recognizer. We get 520,000 formal and 2.28 million informal sentences. We discard the Japanese and then downsample. And that leaves us with 1 million English sentences with binary formality labels. So I'm going to call this the Japanese formality corpus. Even though it's in English, I understand it's a bit of a misnomer. So this is the JFC. Cool. So how do we evaluate the JFC? We should use the same algorithm. So we'll use BERT, and we will fine tune it on JFC. We will also fine tune it on other data sets and see which classifiers perform better. And if our classifier fine tuned on our data set performs better, then our data set is very good. So the data sets that we're going to compare against, there's 3 of them. The first one is manually labeled formality data. So this is the data from before. Annotators give scores, we average the scores, we threshold it at 0, and then we have a data set. We have the Grammarly Yahoo Answers formality corpus. This is a corpus of parallel formal and informal sentences. So annotators were given informal sentences, asked to rewrite them to be formal, And then you have pairs of sentences that say the same thing, but are now informal. This data set is super popular, and a lot of people use it for style transfer. For our purposes, we will be taking out this pairwise relationship and just giving the sentences the labels for comparison. The third data set is an interesting one. There's actually been previous work done on something, approximating our work, but with German. So German has formal or informal register, but it's only present in the second person pronoun, so the word for you. So this data set, there is 55,000 formal sentences, and we downsampled to get 67,000 sentences across both registers. Cool. So we're going to evaluate on the Grammarly corpus and the manually labeled data. Our evaluation on the Grammarly corpus showed that our Japanese-English data outperformed both the manually labeled and the German-English data. Now, this is an interesting result on the manually labeled side, but I'll save the talk about this for the second section. We also outperform GYAFC and German-English on evaluating on the manually labeled data too. Note that I'm not actually reporting the performance for manually labeled data on itself, because that would kind of be unfair. Of course, it's going to beat our data, but point is that our method performs well on both of these tasks, on both of these data sets. It outperforms the other two on both. So takeaways here is, number one, it's definitely possible to train a pretty good formality classifier without any manually annotated data at all. This classifier is also good across domains. The technique to analyzing Japanese formality is fast, and it works even when the translations and alignments are of questionable quality. This technique can also be applied in any language that has Japanese translations, and you can get a formality classifier in any language. Okay, so why did the manually labeled data perform so badly? As you can see, the recall is really, really low, and the precision is really high. This means that we're barely getting any of the positive class, which is any of the formal sentences. This means that the manually labeled data is labeling almost everything in the Grammarly Yahoo Answers formality corpus as informal. Why would that be? Well, remember, so the manually labeled data was actually sampled from 4 different domains. The one on the far left is Yahoo Answers, and it turns out that it is by far the most informal on average out of all 4. So because of this correlation between Yahoo Answers like topic meaning material and informality, classifiers that are trained using this manually labeled data associate the actual topics that are talked about in Yahoo Answers with informality, not the style. The thing with GYAFC is that it took these informal sentences and told annotators to rewrite them to be formal. So they have the same meaning, but different style. And so the manually labeled data classifier sees the meaning of the sentence and doesn't see the style and says it's informal. So to confirm this, we use the same experiment that we did to get the keys to see what would be the most predictive words for formality in English. It turns out the most predictive words for formality in English, according to the manually labeled data, are America, of the university, investigation, government. All of these are from the news domain, and as we see, the news domain is by far the most formal. This pretty much confirmed our suspicion that there was a pretty big topic bias in manually labeled data. So despite the good performance, it seems as though there's still a lot to be learned for formality classification. Like we said before, formality is defined by the speaker relationship. This means classifiers should not use the meaning of a sentence as a predictor for formality, but it's impossible to normalize for this, right? If there is a bias in your data set, your classifiers will be biased. And it's impossible to ensure that every single subdomain of your formality data set has an equal number of formal and informal, because you can always find a new dimension to group things by. So this is where adversarial decomposition comes in. So we did a bit of a proof of concept study. We wanted to take an input sentence and decompose it into meaning and style. The details of this architecture, I don't have too much time for. Point is that it takes sentence, splits it up, style vector and meaning vector. Does it work? Actually, yeah. So this is Grammarly Yahoo Answers formality corpus. The untrained vectors, so red dot means informal and blue dot means formal. Untrained vectors, kind of a mush. Style vectors, perfectly separated by informal and formal, and the meaning vectors are all kind of a blob. This is pretty cool. It would be much cooler if this worked as well for the other data sets. Reminder that Grammarly Yahoo Answers is a parallel corpus. The only thing that differs is the style. The meaning does not differ. In the Japanese formality corpus, there are still correlations. We can imagine that these clusters are probably from different source material. Same thing happened with manually labeled data, but I do have faith that this technique could be used in the future. The accuracy of the decomposed vectors actually goes up in proportion to the amount of bias that's in the data set. So GYAFC got a huge boost in performance from 62 to 96. JFC got a slight boost in performance, 6%, and then manually labeled data saw no boost in performance. And like I said, this is proportional to how biased the data set is. Anyway, takeaways, adversarial decomposition has a lot of possibility. I do think that if the technique is refined more, that this would be the avenue for making sure that our formality classifiers will generalize to new domains and we won't run into that problem that the manually labeled data has. Okay, to conclude, sentence formality classification is really hard. Essentially, for a lot of these sentences, it's an impossible task, right? Sometimes the formality of a sentence is just ambiguous and there's really not much we can do. But that being said, formality classification is far from hitting that ceiling. There's a lot of work to be done. We could run this technique with lots of other languages like Korean. We can attempt to do this in categorical formality. We can attempt to apply this to politeness. I think adversarial decomposition is the way of the future for formality estimation. There's a lot of work to be done. And these improvements actually really do matter. It improves machine translation empirically. We get better information extraction for polite sentences because they're more precise in their speech. Style transfer is predicated on having good formality classification, because otherwise, how would you know if your style transfer model is working? So yeah, point is that it's a hard task, but there are a lot of benefits to doing it. And I think that there's a lot of room to improve. So thank you. Any questions?
Great, thank you so much. So at this point, we're going to open the floor up for questions. And let's see, I'm going to monitor the chat. But again, feel free to unmute and ask your question.
Hey, Liam, just want to say really great job. Super awesome stuff, really cool stuff. I have a quick question. When you were comparing the different data sets' performances, did you also make sure that the data sets had equal size? Like, I guess, how do you know that the discrepancies in your sentence formality classifier were due to the data set being better versus the size of the data set?
So if you're talking about here, let's, hold on. Talking about the original here, correct?
Yes, correct.
Yeah, so are you asking, so the difference in performance on size, I actually did a study where I only fine-tuned on a subset of the dataset versus the entirety of the dataset, and the performance was pretty much identical. This is for the JFC and for GYAFC. So unfortunately, it looks like we're not able to take advantage of the 1 million size or the 100,000, 200,000 size of GYAFC just yet, because BERT is already, pre-trained with quite a lot of the information that it needs. So the fine-tuning on a small subset, the quality of the data matters a lot more than the quantity of the data. Does that answer your question?
Yeah, definitely. Thanks.
Okay, cool.
Great, thank you so much. So in the interest of time, I have, I think this was very interesting and I have lots of questions, but in the interest of time, I'm gonna sort of, hold I'll take my questions offline with Liam. And thank you again, Liam. I'm gonna now we're gonna pass the baton to Yuji. And Yuji, if you can try